Yes, thank you for the reminder. No combinations. We'll talk about combining later. We'll talk about forming gem combinations later and or in the fanfic that I may or may not have allegedly written. We're just going to talk about individual resistors here for these 4 questions. And if you don't know the answer to question A, then your media literacy is entirely on par with what's okay, because aren't these all actually vintage by now? These are only for old people. Isn't it 2010? You should all be playing more video games. There we go. If you don't know A, then play more video games. Nothing to do with physics. It will therefore be on the midterm. Definitely on the midterm. Not joking this time. Huh? Yeah. I've loved all of these video games. Yes. Why do you think I play it? It's also why I lead ham radio clubs and do field day things, is to multiple optimization, minimization problems. Hell, it's why I'm a teacher and a parent too. Oh my God, there's more factorial than anything else. I'm shocked. Oh, Undertale is 2015. Okay, so it's only a decade old. Okay, like 2 more minutes. Let me remind y'all, I don't think this was in the slides. I introduced this as we were talking. Open switch means disconnected. There is no electrical connection right now. Closing a switch means turning her on. Click, close switch. Now there's an electrical connection through there. Lupus. Oh God. Poor Peridot. You guys know what the questions are? I'm going to zoom in on the schematic, in case that helps. Gary. You mean Garnet? Gary? Gary the snail? Oh, I didn't know that was his name. Okay, so I've got some people not listening to instructions. One more time, muy importante. I'm asking for pairs of resistors. Don't tell me about the battery. Don't tell me about combinations thereof. If lapis and diamond are a chonk, you cannot tell me how garnet is related to lapis diamond. Okay, I want to know about, is lapis related to diamond? Yes, no. Tell me about lapis's relationship with diamond. If garnet is not related in particular with diamond, don't tell me that garnet is related in combination to the lapiddiamond, you know? Making sensey? How do I do a highlighter? Where's the highlighter? Is that the highlighter? No. Where's highlighter? Is that highlighter? That's not highlighter. Highlighter. Haha. Okay, so let's do it. Time's up. Here we go. We're gonna play the color trick. True colors. That's why I love. Anyway, moving on. Let's play the color trick. The color trick is as follows. Things are in series if they have a color that nothing else has. Things are in series. I just said that, right? Things are in series if they share a color that nothing else has. A true color deep inside them. Things are in parallel if they have the same pairs of colors on either end. Things are in series if they touch at a point that is not shared. Things are in parallel if they touch at both ends, is the definition that I used once upon a time. As I said, well, if you told me the battery is connected in garnet, in series with garnet, that's correct, but I'm going to ignore that because I'm specifically looking for how can I combine and break apart resistors themselves. Let's do the color for that line after garnet. Garnet connects to pearl and diamond. Garnet is not in series with pearl. Garnet is not in series with diamond. Pearl is not in series with diamond. They have three things are touching the same color. None of them are in series. Pearl peridot lapis. Three things are touching. Not in series. The switch is open. Lapis diamond are touching at a single color. There is nothing else that is green. Oh God, you can't even see that in this projector. Oh, I hate this room so much. The lapis diamond junction, this is supposed to be pale green in here. Nothing else shares this color. Therefore, lapis and diamond are in series. So the correct answer for 1 is lapiddiamond. There is no junction. The switch is open. It goes to an open connection. There's nothing there. When the switch closes, you betcha, don't you know? Y'all see? No? So when the switch is open, the switch is a wire that is disconnected. There's no electrical path here. An open switch isn't a thing. The junction up there, that dot doesn't go anywhere. This is not part of a circuit. There's no possibility of current going that way. So lapis diamond, don't just look for dots. Remember, the book, the homework system, and where I steal my graphics from usually doesn't always include those dots. Don't look for the dots as there's a third component connected there. You got to think about where's this going? Is there actually a thing there? Okay, now let's redo this, but let's have the switch closed. Well, actually, I don't need to change anything. With the switch closed, I could simply say, let me make this actually look like it's closed. With the switch turned on, then diamond, lapis, and the bottom end of peridot are all green. That destroys the seriesness of lapidot and diamond. However, now Paris and lapidot are together exactly as I thought they should be. Lapis and peridot are both, what is that, fuchsia to green. So once the switch is closed, I want to answer this in lapis and peridot. None. None. So before the switch is being closed, there is only a series to be seen, lapiddiamond. After the switch is closed, there's only a parallel to be seen, peridot. Paris, peridot, lapidot, whatever. Whatever. Turn to your neighbor and ask them a question about series versus parallel, and then I will answer the question for you. Okay, and now let's do some addition. No, now let me ask a question. Question me. Give me a question. If you got something wrong, where are you struggling? Now let's see if you've got the addition formulas right. All these are 5s except for diamond, which is 10. Find the total resistance when open. Find the total resistance when closed. What are those? Questions F, find total resistance with switch open. And G, find total resistance with switch closed, which is to say on. Yeah? You want me to zoom back in? Correct. Turned on, connected. I mean, yeah, that's fair. That's a mood. Do you guys still say that, or is that like so 2014s? Okay. Amps? What you talking about? Amps? Amps? I'm asking for total resistance, yo. I mean total resistance. Ohms. No. No. Why? No. Oh God. I found the one person who accidentally read my fanfic. Shouted no in their answers lots of times. Okay, question, someone is asking me for an open or a closed switch. Question F is, suppose the switch is open, find the total resistance. Question G is suppose the switch is closed, find the total resistance. Use what I just gave you as a big hint for a starting point. And go from there. Oh, good, someone got it right. Two people got it right. Yeah. Three people got it right. But it looks like this is something we need to review. Okay, again, the questions. What I'm encouraging you to work on right now, F is find the total resistance of the circuit shown, assuming the switch is open. Question G, find the total resistance of the circuit shown, assuming the switch is closed. All of the resistors but diamond are 5, diamond is 10. Looks like I've broken you all on the second one. And someone wants me to zoom back out. Here we go. Except for the silly question there. Can you all see that? Yeah, this is good. This is good. Here's where we need to practice. I'm going to give you 2 more minutes, though. Okay, let's do 1, and that'll hopefully, if you're stuck on 2, maybe doing 1 will help you. We'll have reviewed skills that have been a bit dusty. So what did we decide first is the first thing that we can analyze. If the switch is open, I said the only series or parallel that there is to be seen is Lapa diamond. Lapa diamond is in series with the switch open. There is no connection where Lapa diamond connects. So what I would do to analyze this is I'd say lapis and diamond are in series. That equivalent 10 series 5 is 15 ohms. Second step I would take is to say, all right, that 15 ohms, Lapa diamond connects at this end and this end to pearl on this end and this end. Lapa diamond, 15. Parallel pearl, 5. 15 parallel 5 is what? 3.75? 5 parallel plus 15 is 3.75. Remember the parallel formula. There are 2 versions. Sum of the reciprocals, take the reciprocal, or there's an easier way to do it when there are just 2. Product over sum. 5 times 15. Oh, well, that's not that bad. 75. 5 plus 15. Oh, that's really not that bad. 20. 75 over 20, 3.75. You future doctors need mental math tricks for MCAT. I'm allowing you to take this with calculators, but hint, pay attention to this for my future doctors. All right, so what do you see then? Garnet is in series with Gem Monstrosity, is in series with Peridot. 5 plus 3.75 plus 5, final answer, 13.75. Yes, absolutely. Do you see that I've got a 15 in a parallel with 5, first off? Okay, so there are two versions of the formula. You could take the reciprocals, add them together, take the reciprocal. Or if you find a common denominator, this is equivalent to R1, R2 over R1 plus R2. That looks like times again, doesn't it? So if I plug into the formula, 1 over 1/5 plus 1/15, or 5 times 15 over 5 plus 15, either answer 3.75. Yeah, happy? Good. Other questions? Give me a question. Give me a question. No, you don't like it. Tell me why. Where? What's hard? Where are you struggling? So I didn't absorb Peridot until the final step. I saw that pearl, lapis, diamond all glomp onto a single clump. Okay, how is that connected to Peridot? Remember, an open switch might as well not be there. There is no open switch. Open switch unexists. You can ignore it. So the Paris diamond, pearl, lapis, diamond, together has one output. That one output of that is there along that line. Nothing else is touching that line but pearl, lapis, diamond on top and peridot on bottom. Those are in series, man. Series. Does that taste better? No, you still don't like it. Tell me why. Tell me where. Keep asking. Ask until it clicks. And other people ask. Other people ask. You ask. Yeah, ask me questions. 5, 5, 3 3/4. There are 2 5s. I just did the last step of adding all 3 together at once. Good, though. Other questions? Do you want to take another stab at G? Let's have a show of hands. Who wants more time to rework G? I'll tell you, very few people got it right. Okay, have another shot at G. Leave it in G. Edit response and change your answer to G. Don't put it in H. We're going to need all the letters we can get. I went all the way through Z with the 3 o'clock section. Good job, Mackenzie. You're the first one to get it. She's got it. She's got it. Hint, remember, the first thing that we discussed is peridot and lapis are now in parallel. When you analyze, you can replace peridot and lapis with a single resistor, lapidot. And I'm going to call that time. Okay, I don't want to spend all day on circuit analysis. Doing circuits is important. It's a lot of what we did in this class. But I want you to understand the whole semester, not just what we did for a quarter of it. We're not going to spend the whole time on it, but we are going to do a second one after this because one person got this right. 9.2, I believe, ohms. Let me step you through the first step, though. We take one step. I want you to retry this after. Peridot and lapis are in parallel once the switch is closed. Yeah. Making sensey? If they are in parallel, I could replace them with a single resistor of equivalent resistance. I'm going to replace peridot and lapis separately with a single resistor called lapidot of resistance of their equivalent resistance. What is 5 parallel 5 equal? 2.5. Lapidot has a resistance 2.5 ohms. If you are struggling with this, which is, okay, I'm giving you a challenging problem here, but only one person in the room got this right. So let me encourage all of y'all, except that one person, redraw the darn circuit, replacing or cutting out redraw the diagram with only one equivalent in place of the multiple that there are. If you're having trouble seeing how this connects, this might be a useful trick. Do you guys see that lapidot is equivalent to lapis and peridot separately? It started at the same place. The things that were connected to them are connected at the same place. They ended at the same place. The things that were connected at that end are still connected there. Yeah? Okay, now let me challenge you again. Find the equivalent of garnet, pearl, lapidot, and diamond all added together. I'll make this a separate one because I want to give you guys another shot here. Question H, find the equivalent of the circuit. Question, yeah. No, it doesn't matter which one you erased and replaced. Try drawing two equivalent circuits. Erase lapis and change peridot's name, erase peridot and change lapis's name. Either way, the ends that are connected are still connected to the same things. Good, Harley. Ricardo. Delilah. Okay, so for at least several of you, that seems to make the big jump forward. Cougar, good job, good job, good job, good job, good job. Kendra, I mean K-Money. Hey, just to check, that's not offensive, right? Okay, because I'm gonna run into a random Kendra in my next year's class and accidentally say, oh, K-Money answer this. And Just want to make sure that I'm not going to get in trouble with the dean if I accidentally turn Kendra into K-Money in the future. And Kendrick, good job. Alex, good job. Piper, good job. Wow, okay. It's trickling in. It's trickling in. Good. I'm going to give you guys one more minute, though. The question, Kylie, is what is the total resistance of this circuit? Brandon, Sammy, Marissa. All right, so Alex, let me encourage you to ask questions like this because what you heard is a lot of people are struggling with this. Okay, time's up. What I see is if I do my parallel and series combinations, if I do the color trick, if I look at what is connected only to what, I see that Pearl and Lapidote are the only things touching at this point. Pearl and Lapidote touch at this point, and nothing else touches at this point. There is no third path for electricity to flow. Anything that flows out of Pearl has to go into Lapidote. Five series, 2.5, 7.5. And because it seems to have made the enormous difference to at least a dozen people on here, I'm going to erase and replace. Instead of Pearl Lapidote, I'm going to have Perladot. And Perladot is a 7.5 ohm resistor. Wait, that needs to be bigger if I'm going to have any hope of doing it. Z.5. What am I smoking? 7.5 ohms. Now what is connected to what and how? Perlapidot and diamond are in parallel. They're touching at the top, they're touching at the bottom. 10 parallel, 7.5. Goes by the name of 4.3. I'm plugging into my formula. 7.5 times 10 over 7.5 plus 10 is about 4.3. Or you could take the reciprocals, add 1/10 to 1 7.5, and take the reciprocal of that. Either way, the answer is 4.3. Oh, I thought you were saying gracias to me. Okay, at the end of the day, Garnet is in series. Series 5 plus 4.3 is 9.3. Correct answer is 9.3. And crud, I wanted to leave this readable as the PowerPoint, as the PDF that I intend to upload. So I'm going to revert to the original state here. What was that, 9.3-ish ohms? Okay, so what I'm seeing is that another practice problem this type would be helpful, even though we have miles to go. Let's do it. Hell, let me be sadistic. I'm going to give a very slight modification on this. Not sadistic. Let me be lazy. No. What should we name these? How about resistors 1, 2, 3, 4, and 5? And their resistance values are all 1 ohm, just to screw with you. So these numbers are names, not values. Yeah? Okay, what are we at? Question H. Find R tote if switch open. And I. Find R tote if switch is closed. Yeah? All the resistors are 1 ohm. I'm naming them numbers so we can talk about them intelligently later, instead of just saying this one, that one. We already did H, for dog's sake. IJ. It's I and J. H was my follow-up before on giving people another chance on G. Odd named resistors are 3 ohms. Even named resistors are half their resistance. No, never mind. Sure. You want me to color the wires? Do the color trick? There's the open coloration. Closed changes that, of course. As a hint, I've colored the wires in the open configuration. Closed changes it, though. I'll give you a hint. It's not the same. Closing the switch changes it. Wait, let me double check that statement before I'm sure of that. I was wrong. They end up being the same. That's not generally true. It's because I chose them all to be the same resistance. Well, that's embarrassing. No, but the evil laugh backfired. I was wrong. They are the same value for each. But the process, we're going to talk through the why. The identifying seriesing and paralleling is important. Since I chose them all to be the same resistance, as it happens, the answers are the same for each of these. One more minute. And let me emphasize again, if you're getting funky numbers, all the resistors values are 1 ohm. I'm naming them numbers to be silly. And because we need to have some naming way to name things so that we can refer to them instead of just saying this one, that one, the other one. But the numbers here are not their values. That's why I put them in quote marks. Might as well call them R1, R2 if you prefer. Okay, time's up. 2 and 4 are in series. 3 and 5 are in series. Series, 1 plus 1 is 2. 1 plus 1 is 2. The 2-4 combination is in parallel with the 3-5 combination. 2 parallel 2 is 1. Resistor 1 is in series with the 2, 3, 4, 5 combination. 1 series 1 is 2 again. Final answer for question I is 2 ohms. Now let's close the switch. With the switch closed, 2, 3, 4, and 5 are all the same color at their junction. Oh my God, that changes things. 2 and 3 are now in parallel. 4 and 5 are in parallel. 2 is no longer in series with 4. 3 is no longer in series with 5. Do y'all see that? That's big. That's big. At the beginning of the semester, well, when we first introduced this, a whole bunch of people would be very confused at how 2 is no longer in series with 4. Yeah, do you want to ask a question? Okay, 1 parallel 1 is half, 1 parallel 1 is half. The 2, 3 combination and the 4, 5 combination are in series, though. Do you see that? That might be the subtlest thing. Do you want me to redraw it? Okay, let's redraw it. Instead of having 2, 3, I'm going to draw a single resistor. Instead of having 4, 5, I'm going to draw a single resistor. Look, the 2, 3, 4, 5, this point is only one thing. The 2, 3 resistor has only one bottom. The 4, 5 resistor has only one top. 2, 3 is in series with 4, 5. So final answer here is 1/2 series 1/2 is back to 1. 1 in series with 1. 1 ohm in series with 1 ohm is still 2 ohms. And I'm going to leave this in a state that it's still legible in the PDF. Okay. Final questions about resistor addition. We're not going to do this again, either today or Wednesday. Unless I get a final question, I'm going to move on. This is a big part of the class. It's not the only part of the class. So let's move on. Okay. Question K. An upward directed proton enters a downward directed enders. Oh, we're not playing that game. Yeah. Velocity is upward. We're going to change the kind of particle. The field is downward pointing. We're going to change the kind of field. And I want you to find the direction of the force, just the direction. B is magnetic, by the way. Right hand rule. No spoilers if you were in the 3 o'clock class, yeah? Oh, I am so totally asking this on the final. Find the direction of the force for permutations. Sabrina, be more specific. That could mean a couple of different things. Tell me the direction of the force. So for K and L, I've got a magnetic field, proton and electron. For M and N, I've got an electric field, proton and an electron, respectively. I'm asking for the force in each of these cases. Not work, David. Not work. Force is not work. Okay, one more minute. Hey, by the way, what do I mean when I say an upward directed proton? What does that mean? What am I specifying about it when I say it's an upward directed? Velocity is up, at least initially. Hey, time's almost up. Jacqueline, congratulations. You're one of the very few 100%. Good job. Okay, Christian. Okay. Learn from it, though. Okay, I'm gonna say that's time's up. And it looks like this is another thing that we definitely need you to review. Correct answer are no force, down, up. Why no force? Give me the finger, everyone. Give me the finger. No, not that finger, these fingers. Okay, now I want you to point your velocity finger up. I want you to point your magnetic field finger down. So I want one finger to go up and the other finger to go down while still remaining perpendicular. You can't do it. You cannot have V up and B down and V still pointing up while still remaining perpendicular. Remember, slide 1 of the right-hand rule was if they are going parallel, if V is along a field line, no force. You only get magnetic force when they cross. Now don't get mad, don't get cross at that. What if no. Let's answer M and N before we move on to an alternate. What if a proton is moving with upward velocity? Well, I don't need to care about the proton's velocity. All I need to know is the sign of its charge. A proton has a positive charge. Force and field point in the same direction. Q times E is in the same direction as E. So the direction that a proton would feel force is down. Electric field points down, electric force points down. An electron, Q is negative. Force is Q times E. If E is down and Q is negative, force is up. The negative down direction is also called the upward direction. Yes, no, maybe so? I totally reserve the right to ask you trick questions. Like, the answer is no force. Just because a lot of the time, none of the above is not correct on a test, you can't always rule that out, like, at all. All of the above and none of the above will totally be valid answer choices on my tests. Okay, what else did the 3 o'clock struggle with? Oh, right, yes. What is Dr. Tucker's least favorite equation? I'm sorry, what is the defining equation for voltage? What is the defining equation for current? What is the defining for resistance? If you have the same answer for OP and Q, you may wish to reconsider your life decisions. Also, I reserve the right to make questions on my test worth different numbers of points. Like, for instance, maybe one of the questions will be worth half the exam credit, and it will be a question that I've answered no fewer than a dozen times in the semester. Hint, hint, hint. Hey, don't tell me the units, by the way. A lot of people have got this, it is stuck in their heads. If I say what are the units for what is the defining equation for velocity? What is the defining equation for velocity? Would you say m divided by s? Those are the units of velocity. The defining equation for velocity is delta x over delta t, or displacement divided by time. Yeah? Don't tell me the units. Not what is 1 volt equivalent to. Then you could tell me units. Tell me the equation. Okay, 1 minute left. I want to see all your answers. And time's up. Show me your answers. And then I will show you the way. Or possibly the way. Oof. Okay. So yes, I guarantee you that some of these equations will be on the final. In particular, I think V equals IR will be worth negative 50 points. If there's no resistor, what's V equals I times R supposed to tell you? Again, I've got a quarter of the 3 o'clock class telling me this and almost 20% of y'all telling me this. V equals IR has no meaning if there's no R. I know you love pirates just as much as I do, but there's not always an R. The meaning of voltage is its energy concentration, how densely packed the energy is per electron. Energy per charge. Joules per coulomb is the units. Current is a flow rate. How ultimately count the number of electrons that pass a point in a circuit while your stopwatch is ticking from 0 to 1. That number of electrons divided by the Coulomb constant is your current. The number of electrons that pass a point per second. Now, we don't actually measure in a number of electrons. We measure in electrons per Coulomb is our unit, the unit of charge. But current is, the meaning of current is charge per time. The defining equation for resistance is volts per amp. And I want to make something very, very, very clear here. Rho L over A tells us what gives a resistor its resistance. There are more kinds of resistor than I have taught you about. You can make a resistor out of different shapes that aren't cylindrical cross sections. Those resistors don't have rho L over A as their formula. What is true about those different kinds of resistors is their materials and their shape and size controls their resistance. Volts and amps don't control the resistance of a resistor. But every resistor has a constant volt to amp ratio. That ratio is its resistance. You don't have to have amps through a resistor for it to have that resistance. But anytime something has a resistance, it has this ratio as constant for any voltage and any current going through it. The defining equation for something is not always how would you find this value of something. The definition of resistance, whenever something is a resistor, it has a resistance equal to the voltage to current ratio. How do you measure that? How do you find that? What gives that value? What could you do to predict it? That's a different question. The defining equation, the central, the core, the essence of resistance is it is the ratio of voltage to current. You can't have voltage over current squared and still be a resistor. You can't have charge per volt and still be a resistor. Then it would be a capacitor or something. Many, many, many people got the current one right. Many, many, many people got many people are getting many of these right. Good. Keep it up. I don't want to bang on that drum though. We're not having too much time left, so let's Let's do a couple more. Let's do different ones. What letter comes after Q? That's right, T. Very good. An electron, which I'll remind you. Details. But thank you for being the one person to point that out. How do I want to word this? How do I want to word this so as not to give it away? Here. We'll do this, a couple of tricky capacitor ones, and we'll call it a day. Sorry? Oh, for fork's sake. I forgot the starting time and the ending time for the class. I thought we were... Here we go. Here's what we'll do. I will answer in 1 minute. Thank you. Here are the answers. I'm giving them to, I should have given you more time, but I want to have time to actually say words here briefly. Electrons don't want to go to negative. Electrons are repelled by negative voltages, other charges. Electrons seek higher voltage. They seek positive charge and that which surrounds positive charge. You have to do work. You expend energy. You push the charge, the electron, where it don't want to be. Its potential energy goes up as you push it where it doesn't want to be. A proton seeks lower voltages. A proton is attracted towards negative charges that exude negative voltage. A proton will lose potential energy, lose potential energy, gaining kinetic energy out of this. It loses, its potential energy decreases. The electric field gives it energy. It could maybe speed up as it goes that way. I could increase my kinetic energy because I have lost potential energy. We're out of time. I love each and every one of you. I am posting this on the what's it? I did different questions for the 3 and the 4:30 section. So I think because for your benefit, I will stay after and answer all the questions that I did for the 3 o'clock. You should, if you rewatch the video, the last few minutes of this are going quickly through those, but be aware that there are 24 more important questions that you can get answers to. See you on Wednesday, or you could stick around if you want to see the first 24 problems done correctly. No, our lab is canceled. Tuesday lab is canceled. My Tuesday lab is canceled. Wait, Huston still does. Yes, sorry. Sorry, but it is short. All of this will be uploaded. Yes, I swear for realsies this time. Yes, I can upload everything. Yo, Kendra.
Tomorrow,
Okay.
because maintenance has to come and fix some stuff in my apartment.
That's okay. Let me know if I can help though, Kendra.
On Wednesday, it's gonna be like the similar review like today.
Yeah, just, I mean, different topics, but yeah. I think this is the most helpful thing I could do for you. Ciao. Looking forward to it. Okay, so for those lucky few, for those 4 who are sticking, yeah, question first.
So hard for it on that. The and how it goes doesn't define each side. Change each side. Is that like a double-edged sword of some sort?
So there is a subtlety in distinction here. What gives a resistor its resistance is its length, its cross-section, its size, its shape, its materials. If you don't apply electricity to a resistor, it still has its resistance. The nature of resistance itself, though, is that there is a constant ratio between voltage to current in some components. Those components are called resistors. So the meaning of resistance is that V over I is a number. That number we define to be resistance.
Define equation of I divided by okay.
Just like for capacitors, the essence of capacitance, charge to volt ratio, is a constant. Q over V is the defining equation for capacitance. What gives the parallel plate capacitance its capacitance is not the charge, it is not the voltage. If you change the charge on a parallel plate capacitor, that doesn't change its capacitance. The value of capacitor's capacitance is determined by A, epsilon, kappa, and D. A epsilon not kappa over D is the capacitor, how to find the capacitance of a capacitor. But the defining equation for capacitance, Q over V.
Trying to define this like in a real life actual capacity.
If I give you a capacitor, its capacitance is set, it's fixed. You could calculate, you could figure it out based on its geometry and its materials. But changing the charge and the voltage doesn't change that. But that doesn't mean that the definition of capacitors, you can have different kinds of capacitors that aren't parallel plates, and those don't have A epsilon kappa over D capacitance. Every capacitor has a constant charge to volt ratio. Once you have that capacitor, its charge to volt ratio is its capacitance. You're welcome. Okay, So for the sake of the recording here, I'm going to go through this time efficiently. I encourage you not, if you are watching this recording afterwards, thou shalt not just look at the answers, thou shalt try the problems and then listen to the answers and explanations. You lucky few who are here, I'm going to give you like 5 seconds to look at this. Great. Well, you've already seen this, but it's worth it to test yourselves again. The correct answer here is very clearly She-Ra, just kidding. Definition of voltage, the defining equation for voltage. Oh, this was given in both sections, energy per charge. Defining equation for current. Current is defined as triple equals charge per time. What is always the same for a battery? A 9-volt battery does not become 4.5 volts just because I attach it to a circuit. Its voltage, that which gives the 9-volt its name, is that. I made a caveat for the 3 o'clock class. Let me admit it here for on the video. If you are taking MCAT, you will learn that there is a difference between cell and terminal voltage. There is something called an internal resistance, and a 9-volt battery does not always measure 9 volts in reality. That's a more sophisticated model that goes to the next level of complexity beyond what we've done. If you want to find out about what cell voltage is, terminal voltage is, stick around, I'll tell you afterwards. But that is beyond the scope of what I will test on, so I'm not going to include it right now. But you can ask. It's not even that hard. What is the same for resistor? It's resistance. Okay, so if I change the voltage across a resistor, this is a question I totally could ask. If I double the voltage across a resistor, current doubles. If I halve the current through a resistor, its voltage drop halves. The resistor's resistance is set by the properties of the resistor. Equation for electrical power, P equals I times V, gives you the power. Do note, however, that is not the defining equation for power. The defining equation for power is energy per time. Define series, same color, not shared by others. Defining equation for power, triple equals energy divided by time. If you multiply these equations together, V times I, energy per charge, charge per time, doesn't charge cancel? And you're left with energy per time? Energy per time is the defining equation for power. That's why IV is power. Series, same color, nothing else has. Parallel, both ends have the same color. That's in the color trick, as I term it. Another way of saying series is two components that are touching at a point that is not touching anything else. Parallel is their left ends are connected and their right ends are connected directly with wire, no other components intervening. I'm missing the letter P here. Question I, which direction is a northward directed electron pushed? No force. Oh, look, question J, there we go. Power is defined as energy per time. The series addition equation, 20 series 30 is 50. The parallel addition equation, whoopsie, parallel addition equation, 20 parallel plus 30 is 20 times 30 over 20 plus 30 is 12. Then I drew a god-awful monstrosity of a circuit and analyzed it, and sadly, for the purposes of this video, I have forgotten exactly what I drew. So let me draw some other god-awful monstrosity. Do you happen to have the first god-awful monstrosity, perchance, in your notes? Pity. Okay, I'm going to leave M through R as an exercise for the student. Draw a circuit and practice analyzing series and parallelings. I encourage you to meditate upon this. Draw your colors and identify, check yourself before you wreck yourself. Are they in fact sharing a color, but nothing else has that color? Are they in fact both the same color on both ends of them? No matter what you draw, unless you run into a very couple of exceptions, you could always combine at least one series or parallel. There are circuits where you have nothing in series or in parallel. You are unlikely to guess that topology. It's rare. As long as you draw circuits with fewer than 5 resistors, you cannot draw something without series or parallel while still having a complete circuit. So practice for yourself. And if you run into questions, anyone who's watching this video sitting in this room or who exists on planet Earth, if you email me and ask me, I will not be able to resist the nerd snipe. I will answer the question. Promise. Hopefully, even before the exam. Defining equation for capacitance. Capacitance is charge per volt. Force between 2 point charges, KQQ on R squared, or D squared if you choose. Electric field is defined as force per test charge. Capacitor energy equation, energy stored in a capacitor is half charge times volt, Gesundheit. Double the area of a capacitor and you double its capacitance. The best gem is not amethyst, it's peridot, just a trick question to fool you there, is question Z. Now, question X and Y will take a second, and I'm going to give the people who stuck around in the room a chance to look at these. Question X is, if you connect a 9-volt battery to a 3-farad capacitor, pull the plates apart twice, double the distance between the plates, and then disconnect the battery, what's the final voltage? Question Y is, connect the 9-volt battery to the same 3-farad capacitor, disconnect the battery, then pull the plates twice as far apart. What's the final voltage? Take a second and think about it. See if you could wrestle with this. You're the TA. You're not in the class. You've seen this before, so it's all David, actually. It's David's all the way down. Actually, you've seen this before, but it is sophisticated, so maybe you want a second to think. Good, good. Then logic through it. Okay, it's both of you. Q equals CV. Definition right there. Bang. It's just like in Family Guy. You want to know who's cute? Stevie. Q, CV. I don't actually know Family Guy. Does that actually work? Is Stevie cute? I'll give you a big hint for X and Y. It very, 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 very much matters the order you do things. If I leave a battery connected, what must stay the same? If I disconnect the battery, what cannot change? If the battery is disconnected, the charge cannot change. If the battery is left connected, the voltage cannot change. Reason with this equation, if charge is kept the same, what happens to V when I change C? If voltage is kept the same, it doesn't matter if C varies, voltage is kept the same, voltage is kept the same. You also do need to remember capacitance is inversely proportional to distance between. And then there's that secret kappa hidden there. Kappa. Okay, so first. If I leave the battery connected, what's that going to cause to happen? What do batteries do? Final answer, 9 volts. What happens if the battery is disconnected? What is held constant? If the battery's, if the capacitor is isolated, there's no way for its charge to change, right? Charge stays the same. What happens to capacitance if I double D? Downstairs doubles. Okay, so C halves, are you okay with that? C is half as great, Q stays the same. What has to happen to V? No? Look, try multiplying up some numbers, some dummy numbers. Say Q is 3, nah, 4. C is 1, V is 4, right? If C becomes half of what it was, is 1/2 times 4 still 4? No, 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 no. Q can't change. C is half as much. What number times a half is 4? Half of what number is 4? No, half of 2 is 1. What's half times 8? 4, right? So this equation works. What happens to V? V went from 4 to 8. Sure, sure. You could do that too. You could do that too. You could do lots of things. You could do, Q is 24 and C is 8. Okay, 8 times 3 is 24. What happens if I have half as much C and the same amount of Q? Half as much C is what? C becomes 4 times what is 24? Yeah, 6 times 4 is 24. V was 3, now it's 6. It has doubled. If the two numbers have to multiply up to the same thing, halving C doubles V. Doesn't matter what the numbers are. You could also express that, for that matter, as V is charge divided by C, and say upstairs no changey, double the downstairs halve the fraction, halve the downstairs double the fraction. Happens to the downstairs of a fraction, the reciprocal of that happens to the fraction itself. And that's it. That's like 50 questions or something. Now let's make some really challenging questions when your brains are properly tenderized, and then I shall crack open your heads and eat your delicious broiled brains. Oh crud, I was still recording. Guess you guys won't die this time.